Okay, well, it's a beautiful day, it's still, so I'm going to fly some FPV today and see how we get on. And in order to do that, I want to set up Acro because I like flying in Acro. I will try and stabilize as well, but there's just a few settings I'm going to change for Acro. So I've got Mission Planner up here for the copter. And the first thing I'm going to do is switch on air mode. And this provides stabilization at zero throttle, basically. So it gives you control of the aircraft while it's falling. And certainly if you want to do sort of flips and rolls with zero throttle, you need this on. The only thing you have to be careful about is that this means that it's stabilizing all the time. So while you haven't taken off, it can mean that you get a little bit the aircraft tries to level itself while it's on the ground, which can lead to some interesting results, including the thing flipping. So you have to be a little bit careful with this, but I have it on. Generally, I find air mode on for Acro, as long as you only take off in Acro with air mode, that's fine. It's landing that with air mode on that's a bit tricky, because what happens is you tend to hit the ground, and because it's trying to stabilize, it bounces, it reacts against the ground reaction. You just sort of get into this oscillation. So what I tend to do is take off in Acro and air mode and then land in stabilize, which doesn't have air mode on, and then I get sort of the behavior I'm looking for without the challenges. So I'm going to increase Expo a little bit to 0.4. So this gives me faster acceleration at the edges of the stick. So in the middle, the stick should give good control, but if I push the stick full over, the aircraft should start accelerating very quickly and enable me to do sort of rolls quite easily. I'm going to increase RPP. So this is the rate at which the aircraft rotates in roll and pitch in Acro. I can't remember I think this is centidegrees, or no, it's not centidegrees, but anyway, there is a change coming up that converts this to degrees per second, which would be much more useful, but I'm going to change this to 10. So I think it's in units of 45 degrees per second. So I think this makes 10 times 45, which is 450 degrees per second. I'm going to take off Acro Trainer. I recommend you don't do this unless you're very familiar with Acro. So this allows me to go beyond 45 degrees, so I can sort of do a complete roll. So if you're learning Acro, leave this on. If you're very confident in Acro, obviously take that off. And then similarly with yaw, I'm going to bump up the yaw piece so I can get faster yaw rotation. And then the final thing I'm going to do is, well, let's just write those out. Okay. And then the final thing I'm going to do is change the input time constant. There we go. So this is all related to pilot feel. So I like quite a crisp feel, so I get a fairly good reaction to my stick input. In fact, it says 0.1 is crisp, so I like to go for 0.08, which gives me a super crisp feel. And it just doesn't feel sloppy, which when you're buzzing around kind of is what you want. But if you want something a bit more soft, then you can increase this. So I'm going to set that like that. Perfect. And then the other thing I'm going to do is check the SD. So I'm going to be flying an FPV. Okay, so this is the OSD configuration screen. So this is in config onboard OSD. And the defaults are pretty good for me, so I'm kind of happy with those. There's basically only one screen. I'll just check the settings here. Yeah, so I'm just going to make a couple of changes here. So one is the OSD Chan change. I'm going to change this to RC7. So this means I can use the switch on RC7 to switch OSD. And then the other thing I'm going to do is enable, so there's also OSD parameter configuration, which is quite useful, so I'm going to enable that. That's OSD5. I'm going to enable that. There's also OSD6, so it gives us two sort of default parameter configuration screens, so I'm going to enable both of those. Whoops. And then what I'm going to do is check that, I won't be able to video it, but I'm going to check that those two things are working correctly in the OSD. Okay, so I checked the OSD and that worked fine. One small change I'm going to make, so if you remember, I've got radio 7 for switching the OSD panel. And what I'm going to do, so by default this just is a toggle, so every time you switch it, it changes screen. But actually what I want is, this is a 3-position switch on this transmitter, and so I want low to be the regular OSD. I want the middle one to be first parameter configuration, second one to be second configuration. So I've got 987 PWM value, 1500 and 2010. So I'm going to go to the OSD configuration. Oops. And we're going to have OSD, and it's still channel 7. But I'm going to change the switch method to PWM range. Okay, so, and then for, let's write that out. And for OSD1, which is the main screen, let me just find this. Yeah, okay, so it's these values here, OSD Chan min and Chan max. So OSD1 Chan min is 900, and I want Chan max to be, well, it was 987, wasn't it? So, so I'll put it just above that, 987, I'll put it to 1000. And then OSD5 Chan min. So if you remember, this was 1500, so I can just go for 1600 to 1700, makes sense. Sorry, no, 1400 to 1700, so it's in the middle there. And then OSD6 is 2010, so I'm going to go from 1900 to 2100, which I think is fine. Okay, and I'll just check that. Yeah, and that works perfectly, which is great. So on the 3-position switch, each position only selects one screen. It doesn't toggle between them. So that's exactly what I want. All right, I think I'm ready to fly. Okay, I'm back. What a great day. Let's see what happened.
Okay, I'm out at my friend's field, which is where I do all my flying. It's an absolutely gorgeous day, perfect for tuning of this kind. There's literally no wind, zero wind, sunny, still, pretty warm for this time of year, and just absolutely perfect. And it's beautiful as well, so I get to fly in all of this beauty, which is just amazing. Just love it. This is one of the reasons I love this hobby, is just you get to be outside and see some amazing things. I'm ready for the tune. I've got my FPV stuff set up. I've got some Dominator HD2s, which are getting a bit old, but I like them. They do quite well. And IB Crazy antenna, which works really well. And I've got the copter just warming up here, just letting the GPS get a really good fix. I'm going to have some fun with these other two small ones, but my main focus today is on tuning this big one and seeing how it flies with the tune I've got already. So really looking forward to it.
So as soon as I got the OST up, I realized that there was an issue, and the issue was I couldn't see the RSSI. And so what I needed to do, so the RSSI was showing 0, and since I wanted to sort of measure radio signal range, what I needed to do was change RSSI to 3. So that means get the RSSI from the receiver. And so I did that, and then I could see the RSI and measure stuff, and did a quick fly around. But there was a problem. So let's see what the problem was.
So I've done a first pass around with Poshole, just flying around just to check the radio range, and there's a little bit of a problem because the radio range is not good, and at certain points the copter was turning and I'd got an RC failsafe, so I think the tracer antenna are probably being shadowed by the frame somehow, so I need to figure out a better placement for those, because they're not really doing the business in terms of providing good radio range. So in order to compensate for that, I've turned up the transmitter power, but on my other copters I'm able to go quite far with just 25 milliwatts, and that should be sufficient. So I'm going to have to figure out where to put the antenna, but for now I'll just run with higher power and see how it goes.
So radio failsafes, what a bummer, eh? So what I think is happening, and I'm pretty sure now because I've done a bit more testing, but what I think is happening is you can see the Immortal T on the frame here, and I think what's happening is in certain configurations these antennae are being shadowed by the frame. Carbon fiber is a great RF shield and so when the copter is sort of flying towards me, we've got the frame in front of the antenna, then that prevents the signal getting through. And so I sort of consulted various people, and I've got some ideas about how I can fix this. And actually, you'll see this in one of the following videos. But I sort of started to figure out a different way of mounting the antenna to get better range. But I'll talk about that a little bit later. So that kind of prevented me doing super testing, but I was able to fly in front of me and sort of keep the radio transmitter in range. And also, thank goodness for RTL and GPS, sort of EKF assisted modes, because it meant if I hit a radio failsafe, the copter would just switch to RTL and come back to me. So it was very safe to fly, and that was one of the reasons I wanted to get RTL up and running. So I was able to get in a good Acro flight, and I can show that to you now. So you can see as I'm flying around the the RSSI drops very low to about 11, so sort of 99 is the highest. And you can see that nicely in when we're low throttle, it's sort of below 10 amps, and then when we throttle up, it goes really quite high, sort of hitting 40-50 amps. Actually, I did a couple of punch outs and hit 150 amps, I think, so it goes pretty high. The copter's holding position pretty well. It felt pretty good to fly, so I was pretty happy with how it was handling. There's no discernible wobble other than my poor flying, and yeah, it seemed to go pretty well. So I was pleased with that as a kind of first Acro flight. The nice thing about these long-range copters with the big batteries is you can stay in the air for a long time, which is nice. So yeah, so good Acro flight. And then I hit RTL when I've had enough. There we go, and come home.
So that was pretty good, but still quite a lot to do. So I did a few flights in Acro, tried a couple of different tunes, sort of more aggressive tune with higher filter settings and a lower tune. It flies pretty well in Acro, but still the pain is the radio fail-safes, but also I hit sort of pretty high throttle in one of the flights and immediately got vibration compensation on, and I suspect that's not vibration, I suspect that's the mag interference to the compass. So although I've taken some measures to kind of try and get the pigtail out the way and reduce the interference, I think I might have to come up with a better solution than that. Still pretty fun and beautiful weather.
So as I was saying there, when I gunned the throttle, I was getting vibration failsafe. So I really wanted to investigate that. So I've downloaded the logs, and I'm going to take a look now just to show you kind of the thought process and the analysis that the thinking that I went through just to try to figure out what was going on. Okay, so here's the log for that final flight in Acro, and as always, I like to just put up the throttle to see what was going on, and you can see these big throttle spikes where I'd really gunned it up to 0.8 throttle, so pretty high, 80% of throttle. So another way of looking at this, so I was kind of suspicious of the compass, and one of the reasons I was suspicious of compasses was that I'd run another compass motor compensation and found out that the pigtail here was generating a huge amount of interference. So you can see the GPS and the compasses here, and with the battery attached, this pigtail was kind of down about at that sort of angle. And when I ran the motor compensation, I was getting a huge Z offset. In fact, I was getting 100% interference at 50% throttle, which is crazy. There's no way you can sort of fly in EKF assisted modes that way. So what I did was I used a little extra battery strap to strap the pigtail and the battery lead together so that it was more vertical, like that. And then I ran the motor compensation again, and that worked quite well. So I was up to about 40% interference at, I want to say, 70% throttle. So that worked quite well. So so I was sort of reasonably happy with that as a sort of compensating measure. So when I saw the vibration thing here, I was a bit annoyed because I thought, oh, it's the compass again. So so now I've got the log, I can see whether it's the compass. So what you need to do is you need to look at the current. So we can have a look at the battery 0, current, and you can see these big current spikes. Woo!
all the way up to 150 amps. And I have to say, the sound of the motors at this point was extremely gratifying. Just a bit like a sort of Ferrari sort of sound, just a great, great whine. So very, very nice. 150 amps is a lot. So I'm glad I've got that XT90 plug on there. So so that's the current. So what you want to look at is how is the compass varying with the current. So let's have a look. And well, yeah, there is a spike there. There is a spike. I suppose that's quite high, but it's not. It's not. Well, it is, I suppose. So I think the compass interference has got a lot to do with this. It was kind of up here, but right way above before. Now you can see there's a little bit of a spike when the current gets high. But that's enough to upset the EKF. So I think that the compass interference is a problem here, even with the kind of mechanical measures that I've taken. And if I look at, let's say, look at Y is not so bad. Z is, yeah, Z is, I suppose it goes negative, doesn't it? So it's pulling down. So that's why you get this trough here. So yeah, I think that's still a problem. And so I've considered a number of options, but I think probably the thing to try is maybe mounting a second external compass in the front of the copter, far away from the battery leads. So the battery leads are the problem. So what I find is that it's not just the battery leads, but it's the lead end of the battery that has a lot of magnetic interference. So I think if I can get at the other end of the battery, I might be in a better position, especially if maybe I mount the compass sort of underneath and an inch away from the battery. So we'll see how that goes. So the other thing I wanted to just have a look at here is the tune. So let's go back to throttle. And then what's nice to look at is this is a sort of quite a macro level. Roll versus desired roll. Take away the throttle there. Oops, let's do that again. Just so you can see it more clearly. Roll versus desired roll. So you can see these are matching really, really well. So I'm pretty happy with that. So if we zoom in a bit, let's zoom in on here, say. How about here? So there's some error here. This difference is the error, but it's 2 degrees maybe. 2 degrees. And 2 degrees would be okay with me. I think 2 degrees, especially on these kind of fast changes, I wouldn't expect 2 degrees. There's a bigger one here, you can see. So that's more like 3 degrees of error here. But still, there's a rapid change, so it's not too bad. So I'm reasonably happy with the tune there, and pitch I think is similar. Again, you see pitch is very similar. A little bit of error here. Yeah, again, sort of 2 degrees error. Couple of degrees, 1 degree error. It's not too bad, not too bad. So I think that tune's pretty good. The other thing is the noise on the tune. So if I look at the rate values, so it's down to rate here. So if you remember, I was saying you've got to look at the oscillation on the out. You're looking for less than 10%. And okay, just reset this. Out. Here we go. So, and this looks pretty good. This is maybe 5%, 4% oscillation. Pitch.
Yeah, pitch is something similar. So you can't just look at the overall level. You have to look at the kind of the level of about the mean. So if we look at pitch again, so you can see that the mean is varying here as well as the oscillation. And so the oscillation about the mean is only about 5%, which I'm reasonably happy with. So I think that's pretty good. And then your is not bad at all. So as tunes go, I think that's pretty good. And I will consult with Leonard, the oracle of all things tuning, and see what he makes of it. But I'm pretty pleased with that outcome.